Hey guys, welcome back to the channel. So in today's video, we're going to be solving question 85 from the first chapter of the Hibbeler textbook. And we have this boom that is supported by the winch cable that has a diameter of 0.25 inches. And allowable normal stress of this cable is 24 ksi. And we need to determine the greatest load that can be supported without causing the cable failure when the theta is 30 degrees and we have the phi 45 degrees. And we can neglect the size of the winch in here. So if that's the case, basically, we don't consider any diameter for this winch that we have in here, just to make the calculation a bit easier. And so basically we have one condition in this, and that would be the normal stress in the cable. So for the cable, we basically have the force in the cable. We can show it with T as a tension in the cable divided by the area that we have, and this cannot exceed 24 ksi. We're going to go with the maximum of this allowable stress. That way we can find the maximum force, and whatever we have less than that would be safe for us because the cable would not fail, and that would be actually the maximum force that we have in here, or the maximum load that can be tolerated. So this tension here, if it cross multiplying here, would be 24 ksi. Keep in mind that ksi is going to give us the force in kips at the end, and the area that we have in here would be basically pi divided by 4 times the diameter, 0.25 squared. So that's going to give us the force in kips for us. We can cancel out 4 and 24. So basically we have 0.25 squared times pi times 6. And this is going to be 1.178 kips. And if we want it in pounds, we're going to multiply this by 1,000. And basically we'll 1178 pounds. So that's the maximum force that we can have in here. And obviously we are in equilibrium, so we can use our equilibrium equation. Sum of all forces in x direction equals 0, and we have the same thing for moment. So if we draw the free body diagram for joint B in here, what we have, so we have the free body diagram of B. So we have the weight of this box, I can show it with W, and we have the tension in here, and we have the force in member AB, you can call it FAB. And so this angle in here would be what we have in here, which is the angle theta, and from the question we know it's 30 degrees, so this is 30 degrees. And what we have for phi, I'm going to show it in different color, you can see it better. It's basically this angle is what we have in here, which is phi. So our phi is 45 degrees, which is this angle here, 45 degrees. Now we can do our equilibrium equations. In order to find the unknown, we have two equations for fx and fy. And obviously we're drawing the free body diagram for one joint, so the moment equation is not applicable here. So we do sum of all forces in x is equal to 0. This will be a positive direction. So let's see what we have. We have minus t cosine of 30 degrees plus FAB times cosine of 45 degrees equals 0. So we already found t in the previous part, so FAB would be basically t cosine of 30, so 1178 times cosine of 30 degrees divided by cosine of 45 degrees. Let's calculate this. So 1178 times cosine of 30, and we're going to divide that by cosine of 45, and what we're going to get for FAB would be 1442.75 pounds. And what we are looking for is the greatest load or the weight for this load that we have in here. So if we do the sum of all forces in y direction, this will be positive. This time we'll have FAB sine of 45 degrees minus W. And we also have the y component of dt minus t sine of 30 degrees is equal to 0. And basically our W would be FAB, which is 1442.75 times sine of 45 degrees minus t, which our t was 178 times sine of 30, we know is 0.5. And all we need to do is to calculate what we have in here. So basically we have 1442.75 times sine of 45 minus, and that's going to give us 431.18 pounds, which would be the final answer for this question, or the greatest load that can be supported in the system. Hope everything was clear. Let me know if you guys have any questions. We are covering different textbooks in this channel. Feel free to check out the playlist and let me know if you have any specific problem. Then we can cover it in the next videos. And you guys take care. I'll see you in the next video. Have a good one.